Your brain doesn't just react to stress, it physically changes within hours. When you experience stress, cortisol levels spike. Remarkably, just 24 hours after acute stress, dendrites in your hippocampus, the hub for memory, shrink. Contrary to the myth that stress is purely emotional, it's a rapid biological reaction. A study at Rockefeller University showed that in rats, stress-affected dendrite density decreased by 30% in a day. This rapid change can impair memory formation. While you might think stress is temporary, your brain's structure can be altered almost immediately. This raises the question, what else is happening in your brain during stress? It's often believed that stress is uniformly harmful, but your amygdala might disagree. Stress hyperactivates this almond-shaped structure. A study by Harvard University found increased amygdala activity within minutes of stress exposure. This hyperactivation enhances threat detection, sometimes at the cost of rational thinking. Your amygdala, tasked with processing emotions, sends signals that suppress the prefrontal cortex, responsible for decision-making. This is why under stress, your logical thinking might falter. But not all stress responses are equal. The intensity of amygdala activation varies widely between individuals, influencing stress resilience. The idea that stress always leads to anxiety neglects its nuanced impact on dopamine signaling. Within your basal ganglia, stress can dampen dopamine receptor activity. Researchers at Stanford University demonstrated that chronic stress led to a 20% reduction in dopamine receptor availability. This downregulation can dull reward perception, increasing susceptibility to anxiety and depression. Yet, in short bursts, stress increases dopamine, sharpening focus and energy. How stress affects your dopamine system depends on duration and intensity. That variance is why some thrive under pressure while others crumble. You might think habits are immune to stress, but the basal ganglia begs to differ. Stress influences habit formation by activating this brain structure. Neuroimaging studies reveal that during stress, the basal ganglia encodes habitual responses. This is why stressed individuals often revert to old habits. University of Southern California researchers found stress can double the speed of habit loop encoding. This suggests habits formed under stress are deeply ingrained. The myth of stress as a purely conscious challenge misses these automatic, structural responses. Stress imprints on your brain's habit circuits. The common belief that mental resilience is a trait overlooks neuroplasticity's role. Inside your brain, stress affects synaptic connections, altering them. The University of California published findings showing stress-induced reduction in BDNF, brain-derived neurotrophic factor. BDNF supports new synapse formation, so lower levels mean less adaptability. This decrease can impair learning and memory, but it's reversible. Neuroplasticity allows your brain to recover from stress-induced changes, given the right conditions. Resilience isn't just innate. It's a dynamic interplay between stress and your brain's ability to adapt. This dynamic process is key to understanding stress handling. Cortisol does more than trigger a fight-or-flight response. It reshapes your brain. Inside your hippocampus, cortisol reduces dendrite density. Johns Hopkins University researchers observed a 20% decrease in dendritic spines after prolonged cortisol exposure. These spines are crucial for synaptic connections and memory. This reduction impedes your ability to form new memories under stress. While acute stress might enhance memory temporarily, chronic stress leaves lasting marks. Your brain's architecture is altered, affecting cognitive functions. Cortisol's impact extends beyond mere stress response to tangible brain restructuring. The connection between the amygdala and prefrontal cortex is pivotal under stress. Stress increases amygdala-prefrontal connectivity, altering emotional regulation. A study from the University of Pittsburgh found heightened connectivity correlates with increased anxiety. This heightened state causes the amygdala to dominate, suppressing prefrontal decisions. You may feel overwhelmed as your rational brain takes a backseat. Interestingly, mindfulness practices can reduce this connectivity, promoting balanced decision-making. Stress-induced connectivity changes highlight how emotions and logic are intertwined in your brain. This dynamic reveals why some struggle to manage stress. Dopamine receptor downregulation under stress isn't just a chemical change, it's a rewiring. The nucleus accumbens, key in reward processing, suffers under chronic stress. Yale University researchers showed stress decreased dopamine D2 receptor density by 15%. This reduction blunts reward sensitivity, leading to anhedonia. As dopamine signaling diminishes, motivation wanes. Yet, short-term stress boosts dopamine in the caudate nucleus, enhancing alertness. Dopamine's dual role underlines why stress responses differ vastly. Your brain's reward pathways adapt based on stress duration, reshaping motivation. Stress alters the habit loops encoded in your basal ganglia. Stress-induced changes here can solidify behaviors into automatic responses. Research from MIT demonstrated stress accelerates habit formation via corticostriatal pathways. These pathways strengthen habitual circuits, bypassing conscious control. It's why stress can make you reach for comfort food or skip exercise. Stress biases your brain towards routine actions, prioritizing energy conservation. This mechanism reveals why breaking habits during stressful periods is challenging. The basal ganglia's role in habit encoding is amplified under stress. Stress impacts the default mode network DMN, crucial for self-referential thoughts. Under stress, DMN activity increases, leading to rumination. Stanford University studies found stress boosts DMN connectivity, intensifying negative thought cycles. This heightened activity can trap you in a loop of worrying. Conversely, engaging in focused tasks reduces DMN activity, alleviating stress. The DMN sensitivity to stress explains susceptibility to anxiety and depression. Understanding stress's effect on the DMN helps unravel the complexity of mental states. Stress reshapes how your brain defaults to thinking about itself and its challenges. Chronic stress fundamentally changes your brain, unlike acute stress. Over time, stress elevates cortisol, eroding hippocampal tissue. Harvard Medical School found that prolonged stress reduces hippocampal volume by up to 10% in severe cases. This shrinkage impairs memory and learning capabilities. Meanwhile, acute stress can temporarily enhance cognitive performance by activating norepinephrine pathways. The distinction between chronic and acute stress is crucial. Chronic stress leaves enduring scars on brain structure, while acute stress may provide fleeting benefits. Your brain's resilience hinges on stress duration and intensity. The self-help industry often oversimplifies stress management, overlooking complex neurobiology. While mindfulness is advocated widely, it's not a universal remedy. Studies from the National Institutes of Health show that mindfulness reduces amygdala activity by about 30%. However, it doesn't reverse structural changes caused by chronic stress. Behavioral strategies can modulate stress response short-term, but the deep-rooted neural changes require more than just mindfulness. Realigning the brain's stress circuits involves multifaceted interventions. The gap between self-help claims and neuroscience underscores the need for informed approaches. Brain imaging studies reveal contradictions to popular psychology narratives. MRI scans show the prefrontal cortex shrinks under prolonged stress. University College London's research indicates a 5% volume reduction with chronic exposure. This diminishes executive functions like decision-making and impulse control. Meanwhile, the amygdala often enlarges, heightening emotional responses. Contrary to the belief that stress is purely psychological, these structural changes are visible and measurable. The physical manifestations of stress in your brain challenge the oversimplified view of stress as merely emotional turmoil. The reality is far more tangible. The extremes of stress handling are evident in genetic variations. Specific genes affect cortisol receptor sensitivity, influencing stress resilience. Research from the University of Michigan identified variations in the NR3C1 gene that modulates stress response. Some individuals exhibit a muted cortisol reaction, resulting in better stress management. This genetic factor explains why some people seem unfazed by high-pressure situations. Your genetic makeup partially dictates how stress impacts your brain and behavior. These genetic differences highlight the biological underpinnings of stress tolerance. Not all stress responses are created equal. A compelling study from King's College London provides insight into stress and aging. Chronic stress accelerates telomere shortening by 50%. Telomeres, protective caps on chromosomes, naturally shorten with age. This process hastens aging at the cellular level, linking stress to premature aging and chronic diseases. Stress's impact extends beyond the brain, affecting your entire biological framework. These findings challenge the notion that stress is merely a mental state. The interplay between stress and telomeres reveals a biological clock ticking faster under stress. Stress's effects are far-reaching, reshaping both brain and body.